Good morning, everybody. It is Monday and it is the last week before we go back to school. Hip, hip, hooray. I can tell you for nothing, I cannot wait to go back to school and I cannot wait to be able to deliver these lessons to you in person rather than having to do them on videos. However, we have got a week's worth of videos to get through, so let's try and crack on with it and start it off with a good week, a good start, our 7 times table. Your click starter today is to divide these numbers. So use those skills that we picked up a few weeks back now, just to try and keep them nice and sharp. I was really impressed with what I saw when we had our little operations refresher on the addition and subtraction. That seems to have stayed with a lot of people, which is great. And this is how we're going to keep that same momentum building with division and multiplication, just small amounts every day just to keep them ticking over. So have a go at these division questions. To be honest, I expect almost everyone to be able to do the medium ones at least. So have a go at doing the lemon and herb as a little warm up, and then move on to the medium ones, because the lemon and herb ones, they're nice and simple numbers. The first one is a nice easy division that divides into something. The second one's a bit trickier, but maybe a bit more obvious as to what the remainder will be. Can you have a go at doing at least the orange and maybe even the red if you're feeling up to it? Our learning objective today is to discover fractions greater than 1. So we've been looking at fractions, and all the fraction wall stuff that we were looking at last week was fractions between 0 and 1. And as I said to you when we were learning about that stuff, that there are an infinite amount of numbers and therefore an infinite amount of fractions between each number. So between 0 and 1, and then we're going to look at the ones that are above 1 today. So there are more fractions that exist above the number 1. 1 is not the cutoff. So we've got Jamila and Richard, and they are making hexagons out of triangles, which I found to be quite a difficult exercise because of the shape of the triangles that I have on my computer, but they've done an excellent job, and we need to figure out how many hexagons they're going to be able to make with their triangles. So they've got 2 already on the go, and you can see that they've taken 1, 2, 3, 4, 5, 6 triangles to make each hexagon. I counted them all up for you on the table. There's 29 in total, although the question fails to mention that. And they've already used 6 of them to make 1 hexagon. They've made 2 hexagons in total. As you can see, I've tried to replicate them down here. They're a bit squiffy and a bit dodgy compared to theirs, but I hope you'll forgive me. And we've got 12 triangles out of the 29 have been used. So we need to figure out how many hexagons Jamila and Richard can make. Do we need to draw out all of the triangles, or can we use our mathematical skills to calculate the amount of triangles we can use to make hexagons? So, can you copy and complete this sentence? I know the calculation I need to do is because ... Now, because is the most important conjunction in maths. So I would stick my neck out on the line to say because a because sentence means not only do you know what you need to do, but you're able to explain why you need to do it. Such an important and fundamental skill in maths is not only knowing what to do, but being able to explain why you have to do it. Think about the click starter that we did. If you need a bit of help, what calculation you need to do, have a go at writing that sentence out, and I will move on now. So we needed to do a division. We've got 29 triangles. We're grouping them into groups of 6. It just so happens that that group of 6 makes a hexagon. So we're taking a larger number and we're putting it into groups of a smaller number. We're doing a division. So we've got 29 triangles and we're sharing them into groups of 6. I know the calculation I need to do is the division because I'm grouping a larger number into a smaller amount of groups. here are our hexagons then. So, whoops, we've got 6 in this hexagon here, 6 in this hexagon here, and these should be our remaining triangles. So let's have a go at plonking them into hexagons. As if by magic, Mr. Keeler has done it with the click of a button, and here we have 1, 2, 3, 4, 5, 6 in this group here. 1, 2, 3, 4, 5, 6 in this group here. 1, 2, 3, 4, 5, 6 in this group here. 1, 2, 3, 4, 5, 6 in this group here. And if we know our 6 times table, which I'm hoping we'll be a little stronger at, having done all our daily 10 practice with the 6 times table, we will know that 6, 6, 6 and 6, 6 times 4 is 6, 12, 18, 24, and then we've got 25, 26, 27, 28, 29 remaining. So here's all our 29 triangles. We've used as many as we can to make hexagons, which of course are a 6-sided shape, which is why we're using 6 triangles per hexagon, and we've only got 5 left to try and make the 5th one, so we can't. So we can make a total of 4 with a remainder of 5. And you may remember that I showed you a really interesting trick the other day to turn your remainder answer into what would be called a mixed number, which is what we'll find out more about mixed numbers later on, so don't worry about that phrase. But the simple trick is, if you've got an answer with a remainder, then you don't have to write 4 remainder 5. You can actually turn that into a fraction by making the numerator the remainder and the denominator what you divided by, which in this case is 6. And we will go on to prove that a little bit more in this lesson, actually. If we then get rid of this, we've got an answer of 4 and 5/6. And if we look here, how do we represent this as a fraction? So here are our hexagons. Let me zoom out a little bit. Here's our hexagons, and here are the complete ones we had. So there's 1, 2, 3, and 4. And we had 5 left over, so we were able to make 5/6 of a hexagon. If you look, we were able to use 1, oh, I've accidentally rubbed that out. 1, 2, 3, 4, 5 triangles out of the 6 that we needed. Here is the 6th disappearing one that we didn't get to use. So 1, 2, 3, 4, 5. So we had 1, 2, 3, 4 whole hexagons, and then 1 hexagon that was not quite whole, but we can say, instead of saying 4, and we didn't have enough for the last one, we can say, actually, we had enough for 4, and we had enough for 5 out of 6 pieces of the hexagon in the last one. So we were really, really close. It shows how much closer you were to completing that last hexagon. Above, we have 4 whole fractions and 1 fraction that is not whole. We will represent this as 4 and 5/6. So there you go. A really, really simple trick. Just to go over that trick again, all you have to do when you get a remainder is put a little line underneath the remainder, make that the numerator, and then turn the denominator into what you divided by, which in this case was 6, and it gave us the answer 4 and 5/6. If you'd like, have a go at turning these remainders, so you don't have to do any of the working out because it's all been done for you. All you simply have to do is turn these remainder answers into mixed numbers. And you can do that by doing 17 divided by 5 equals 3 remainder 2. You can literally just put an equal sign, and then instead of having 3 remainder 2, you can have 3 and 2/5. And that is because 2 is our remainder, so that becomes the numerator. 5 was our division number, so that is going to be the denominator. And that's how we make our fraction. Have a go at the last two if you feel like you're up to it. And then once you've done that, it will be time to move on to the activities. So I'll say goodbye to you on this video, and if you would need some activity support, then that will be available for you as well.